Hey guys, sorry about that. The ending of that last video got cut off a little bit, but I just wanted to make sure that I reiterated this. So to determine the number of valence electrons in any energy shell, you just have to take a look at the group, aka family number of the element. So like if it's in group 1, it will have 1 valence electron. Group 2 will have 2. 13 or 3A will have 3 valence. Group 14 will have 4. 15 will have 5. 16 will have 6. 17 will have 7. And then 18, of course, we know the noble gases are stable, so they have 8. Okay. Now, based on how many valence electrons, we can tell whether or not they're going to gain or lose electrons and become cations or anions. So the charges here are the oxidation numbers, and this is just a little cheat sheet. So if you have, if you printed out a periodic table, you could definitely write this, but you basically just have to look at the valence electrons, right? Don't let this number right here on this slide confuse you. These are not the valence electrons. These are the charges of the elements in those rows, or in the groups. So the transition metals in the middle, they can be a little bit tricky. We'll talk about them a little bit later when we get to bonding. But for now, all we need to know is number 1, the valence electrons are determined by the group number. Okay, so for these, so the nonmetals on the right-hand side, remember that this is group 13, but it's also 3A. So for any of them on this side, you just drop the 1. So like for 13, it's 3 valence. For 14, it's 4 valence. 15 is 5 valence. That's how many electrons they have in that outer ring. So think back to your Bohr models and the electrons you have in that outer ring. Remember, if they have 3 or less, right, they're going to give them away. So these groups right here, so the elements in these groups, they're going to donate their electrons because then they will be stable. Because if they get rid of all the electrons in their outer shell, then the energy level that's left will be full. So these in group 1 will donate 1 electron. In group 2, they'll donate 2 electrons, and in group 3A, they will donate 3 electrons to become cations. So if they're getting rid of those electrons, they're becoming positively charged. We don't need to worry too much about the carbon group right now because, again, it could go either way because it's got 4. And then, of course, when we have our nonmetals over here, we have them taking on those electrons, because remember, if they have 5 or more, they're going to tend to take them, which will create an anion, because if you're adding negative electrons, then the overall charge will become negative. Okay, so like here, where we have a charge of -3, that means that all these elements will take 3 electrons. All of these elements in this group will take 2 electrons. All the elements in the halogens will take 1 electron. And then, of course, there's not a charge for our noble gases, which are in group 18 or 8A, because they're stable. They're not looking to give or take any electrons because they already have a full outer shell. Okay, so just something to think of. Remember, valence electrons determined by the group number, and then, of course, the charge is determined by how many electrons they are either donating or gaining. As always, if you guys have questions about that, we're going to do some practice today, of course, but if you have questions, let me know.